All right, hello. I had somebody ask me about circles and how we can represent circles with equations. It was a great question. And how do you interpret equations that are given to you and figure out information about the circles? So I just wanted to start with drawing a circle, kind of a reasonable place to start. And when we're talking about equations, we typically have some sort of x and y axis on there. I'm not going to quite draw that on there yet, but I will in just a second draw the x and y axis on there so we can come up with an equation. So when I have a circle, the one thing that I know about a circle, in fact, what makes a circle true, is that from the middle of the circle, from the center to the edge, is always the same distance. And that distance is called the radius. Okay. So it may not be obvious, but no matter how I draw the radius of the circle, I can actually create a right triangle out of it. And the way I create a right triangle is by imagining two axes going right through the center of the circle. So this one I missed by just a little bit. So if I have an x-axis here and a y-axis here, any one of those radii, except for the ones that are on the axes, can be built into a right triangle. So for example, this one right here can be built into a right triangle. This one can be built into a right triangle. All of these different radius lines can be built into a right triangle. And so the idea is that for any of those right triangles, I can use the Pythagorean theorem to come up with an equation about the points that are on the circle. So if I think about this having an unknown x and y coordinate, then I know that the base of the triangle is x and the height of the triangle is y and the hypotenuse of the triangle is r. And so then this is your basic equation for a circle. So this is the very simplest version, x squared plus y squared equals r squared. And all that means is that your circle has a radius of r and a center of 0, 0. So just keep in mind when you get an equation for a circle, the number that you see over here on the right side is not the radius. It's equal to the radius squared. So take the square root, just like when you're doing Pythagorean theorem. So now what do you do if your circle is not centered at the origin? Let's take an example. Let's say that my circle is centered at 3, comma 4, and goes like this. Now, if I want to choose a random point on the outside of the circle, some random xy point, I can still build my right triangle like this. The hypotenuse of my right triangle is still whatever the radius of the circle is. But now this leg distance right here is not just x. It's actually the distance between x and 3. And same idea here. This height is not just the letter y, it's y minus 4. I need to subtract the center of the circle to find the height and the width of the triangle. So then my Pythagorean theorem, my a squared plus b squared equals c squared, becomes x minus 3 squared plus y minus 4 squared equals the radius squared. So if you have an equation like this, which you can kind of think of as like a level 2 sort of circle equation, now we know, okay, same idea, that the radius equals the square root of whatever the number on the right is, but now we have to interpret the center as 3 comma 4. So be careful because in the equation you see x minus 3 and y minus 4, but when you write your center, it's positive 3 and positive 4. There's one other level that gets a little bit trickier, which is if I just give you an equation, something like x squared minus 2x plus y squared plus 8y equals 0. and you have to figure out what the center and the radius of the circle are based on this equation. So what you have to do here is complete the square. So remember, I had it in an x minus something squared and a y minus something squared form. So what I want to think about is, how can I change x squared minus 2x into something that looks like this? And what I want you to remember, I'm going to do a quick little tangent over here. What I want you to remember is that if you have something like x plus a number, let's just say x plus n, and you square it, it becomes x plus n times x plus n, which is x squared plus nx plus nx plus n squared. All I did was x squared, x times n times n times n. In other words, it simplifies to be x squared plus 2nx plus n squared. And the crucial thing that I want you to focus on is that there's a 2 right here, but there's not a 2 when I put it inside the parentheses. So to complete the square, I take my x squared minus 2x and I make it into x minus 1. I take my y squared plus 8y and I make it into y plus 4. The idea there is that I'm following how it's twice as big in the middle, but it's half as big on the outside like that. And then what I'm going to do is compensate for that. If I have a 1 there inside the x, I'm going to subtract 1 because that's 1 squared. And if I have a 4 here, I'm going to subtract 4 squared, which makes 16. And all of this equals 0. So now we're almost done. I've got x minus 1 squared, y plus 4 squared minus 17 is equal to 0. And then I'm just going to make it into the format that we talked about a few minutes ago by adding 17. So now I can tell you that the center of the circle is 1 comma negative 4, and the radius is the square root of 17. So that's how you take the equation and find information about the circle from it. Let me know if you have any other questions, either comment or just get in touch with me some other way. Thank you.